Okay, so the next problem is question 3. What percentage scored below 45 in geography and above 80 in chemistry? Now we're going to look at this in using Excel and an Excel function, which allows us to skip using the Z tables, skip the manual task. And we'll look at just the first part of the question, and you can try the second part yourself. So here's an Excel spreadsheet with the data that I provide with you already laid out. And in Excel, we can use what's called the norm distribution function. So there's the table structure, and we want to insert a function. And it's just in this demo example, the function is going to appear in cell A2, but probably we're looking for a calculation of the geography data, so it probably would be best to put the function in cell C7, but that's a minor detail. We'll go to functions, and in the functions library, we search for the function we want. So we want the one normal distribution, so just type in the word norm, and that'll give you an example of the options. So we pick the one called norm.dist, which is the normal distribution, and here we have the parameters. So again, you can see the typical parameters that you need for the z-score calculate. So what we're going to do is it's not going to calculate the z-score and then work out the cumulative from the table. We just calculate the cumulative directly. So using this here, we use the norm distribution function. We want to answer the question, what percentage score below 45 in geography? Okay, so 45 is a new variable, not in the table. So we type 45 directly into the X box. For the mean box, we put in cell C3, which is the mean for geography. And then for standard deviation box, we put in cell C4, which is the standard deviation for geography. And for cumulative, we can select true or false. So cumulative means do you want the full area under the curve, and if cumulative is set to false, you just don't want the point in the curve. We're always interested in the area under the curve, so type in true for cumulative. So you type in 45 and true, and the other two are cell values, and the answer will come out in the place that you place the function as 0.02275. That means that the percentage you scored below 45 in geography was less than 2.3%. So you can do then the same for above 80 in chemistry. Just remembering when you're trying out the above 80 in chemistry calculation, everything's the same, but you'll always get the people below 80 in your answer. That's the way cumulative distributions work. It's from the left to the right in the chart. So if you want the number above 80, you have to calculate the answer in Excel for below 80, and then deduct that from 1 to get your correct answer. So this is the last part of the example and the last part of Z-scores. So question 4, what mark is required to get in the top 15% in mathematics? This is a reversal of the previous questions. We want to go from a Z-score to an actual score X, not the other way around. So here's the typical diagram for the PDF. So we want the actual score X, not the Z-score. So what actual score on the line will give us the Z-scores that we can compute? So we know that it has to be the top 15%, and that's to the right of the value that we want. But the table of Z-scores, and here we're going to use the manual paper table that I'm providing. So the table of Z-scores works from the left. So it's the area under 85%. That's what we're looking for. So we're looking for 0.85 or nearest on the Z table. So we're not looking at the rows and columns of the Z table. We're looking inside the table, looking for the number there which is closest to 0.85. And when you look through the Z table, you'll find that the nearest number to 0.85 is in row 1 and column 0.04. And where they intersect is a number very close to 0.085. So that's the one we take. So we just take the nearest. So that means that the actual for that Z-score of 0.85, the area on that line is at 1.04, the standard deviations from the mean. So then we can feed that in. So that's the number of standard deviations from the mean. So where is that on the line? Well, if the mean is 85, the average score is 85, the standard deviation is 10. So 1.04 times 10 plus 85 gives us a figure of 95.4. So that means X is equal to 95.4, and anybody who scores 95.4 or 95.5 is in the top 15% of mathematics.